Examination has just been done, 2 days past. So today I have come up with the solutions for the ISS. Okay, so let us start what it is all about. So today I have taken paper 4 for what? 2024. So the ISS examination paper 4 2024. Okay, so the first question, let us read the question together. An electronics company, so it's an LPP program. Okay, it's based on LPP question. Okay, so how we will get that, just see. We an electronics company, so first I told you it has come from LPP, linear programming. Okay, so an electronics company manufactures two type of LED, model 1 and model 2, and the daily capacity of the company is 60 LED of model 1 and 75 LED of model 2, and each model of the first type uses 10 pieces of an electronic component, whereas a model of second type uses 8 pieces of this component, and the maximum availability of this component is what? 800 pieces. So the company is committed to manufacture at least 20 pieces of model 2 per day. And now if the net profit on the sale of these two models is rupees 40 and rupees 30 respectively, then we have to determine the production schedule which maximizes the profit of the company, right? So now let me consider X as a number of model 1 and Y as a number of model 2. Okay, and what will be the maximization of profit? It will be 40x plus 30y. Okay, and I know X is less than equals to 60 and Y is less than equals to 75. Okay, so what is the component availability? Constant. So Y greater than equals to 20, the minimum production. Non-negative constant, X greater than equals to 0, Y greater than equals to 0. So now we need to solve this linear programming problem. We can use a graphical method or a computational tool to find out the optimal solution. Okay, so now the optimal production schedule to maximize the company's profit is produce 60 units of model and 20 units. If you solve, we will get this. Okay, because it's a maximization of 40 and 30. Okay, and so P will be finally 40 into 60 plus 30 into 20, which will come to 3000. Okay, now coming to the second question, that is based on game theory. Definition of the saddle point of a game problem using the principle of dominance to find the optimal strategy of the two players. This is a payoff, it's nicely given. What is saddle point? We all know in a payoff matrix, it is an element which is the smallest in its row and the largest in its column, and it represents the optimal strategy for both players, whether neither player can unilaterally improve their outcome by changing their strategy. So this is the given payoff matrix which is already given. Now we know row 1 versus row 2. If we eliminate row 3 from this, first taking it smaller and greater, so it's 3 5 4 2 5 6 2 4. Which one is greater? 3 greater, 3 greater, 5 greater, 2 greater. So I eliminate this process of elimination, so 3 3 5 2. Okay, right? Now this side column, so which one is greater? This one is greater, 4 greater, 2 are greater, so I cross out this one, so it will come as 3 5 4 5 6 2 3 3 5. Okay, so minimum values in each row: row 1 3, row 2 2, and row 4 3, and maximum values: column 1 5, column 2 6, column 3 5. So what will be the strategy? A should choose to row 2, and B should choose column 2. Okay, so the optimal strategy for player A is to use their second strategy and player B to use their second strategy. Okay, now coming to use Vogel's application method to find the possible or feasible solution to the following transportation problem. It's operation research. Okay, so how we will do? First, this will be the first, we will do the row penalty. Okay, so origin 1, 2 minus 1 comes 1, 8 minus 4 comes 4, 7 minus 6 come 1. Now column penalty on the same pace: 7 minus 2 5, 8 minus 2 6, 6 minus 2 4. Okay, and 8 minus 1 7. Now we have to update the table, and the table will look like 2 2 2 1 it will come to 0. Okay, it will come to 7 5 10 8 5 4, this one 4 3 4 1, it will be cross, it will be 4 3 4 1, like this. Okay, so we have to recalculate again. So how I will do? 8 minus 4 4, 7 minus 6 1, and there this is 8. Okay, now 7 minus 2, 8 minus 6, 6 minus 5. Okay, now allocating to D. In this way you have to do, and you will come up finally to a place where the answer would be coming like this: 3 4 1 2 3 2, and this solution meet all the sum and demand requirement and provides the initial solution. Okay, so these are the 3 questions today we are going to discuss with this much for the ISS 2024 paper. Thank you.